Hello everyone. We are going to discuss on chemical engineering reaction 2. Myself Vivek, assistant professor in department chemical. So the introduction on heterogeneous and reactions is going to be discussed. First we are going to discuss on the rate equation of for heterogeneous reaction, absorption isotherms, rate of absorption and desoption, surface reaction analysis of rate equation, rate convention. So on focusing on to the objectives, we will be discussing on the rate equations for heterogeneous reaction and absorption isotherms. So basically what is heterogeneous reactions? It's nothing but the reactant product, the reactant is converted into a product in the presence of a catalyst in different phases. It may be a liquid, a solid or gas phases. So the role of a catalyst plays here in major, that gives an heterogeneous form to form a reactant into a product. Basically there are two types of heterogeneous reactions. First one is catalytic type heterogeneous reaction, second is non-catalytic type heterogeneous reaction. So the catalytic we see here and non-catalytic type of reactions we see. So based on that we solve the rate equations for the heterogeneous reactions. Basically chemical reaction is of two types, a series reaction or a parallel reaction. The overall equation for a series reaction is given as rate of reaction 1 is equal to rate of reaction 2, rate of reaction 3, and that will be equal to rate of reaction of n times. Whereas for a parallel reaction, the summation of rate with respect to n numbers. So the rate controlling and rate limiting steps that we can understand is we have to assume 5 points for a chemical reaction. For example, let us take a gas and a solid. Gas as A reactant and a solid as a B reactant, that forms a product as R in a gaseous form. The main assumptions we have to make is first order reaction with a gaseous reactant A. There should be no ash formed in the solid surface. Gas is transported from bulk of gas to solid surface. Surface reaction between A and B. Product R is transported from solid surface to bulk gases. So this is the diagrammatic view where a solid is burning with the presence of oxygen and it forms CO2. So in modeling or in a rate equation, we can see a gas film in between the solid and the air which absorbs oxygen and releases CO2. This is the absorption of oxygen and desorption of. So similarly, the absorption is divided into two types, that is physiabsorption and chemiabsorption. So basically all solids are physiabsorption process, whereas some solids are in chemiabsorption process, whereas in temperature ranges physiabsorption takes place in a low temperature, whereas chemiabsorption takes place at high temperatures. And even in heat absorption, physiabsorptions are at low absorption, whereas chemiabsorption takes high heat of absorption. The important parameter that we have to see here. So likewise we will have reversibility, coverage, rate, everything we will compare here. So the major important parameter we have to see is for the physiabsorption we determine the surface area and the pore size of the catalyst, whereas for chemiabsorption we see the active center area and the surface reactive kinetics. With this we can conclude that heterogeneous reactions are faster compared to homogeneous reactions. So we have discussed here the rate equation of heterogeneous reactions and absorption theories. Thank you.